In this video, I propose new dynamics hypotheses with surprising results and numerous remarkable scientific and technological applications. I am asking you to analyze it, to dissect it, and to find its weak points. And I would be happy if you could refute it and communicate your suggestions to me. My name is Gabriel Barceló. I studied physical science in Madrid, and I am a doctor of industrial engineering. More than 20 years ago, I initiated this fascinating investigation project, which we named Theory of Dynamic Interactions. In this scientific project, we have analyzed the movement of objects that are submitted to multiple rotation speeds, as is the case for the spinning top, the boomerang, the hoop, and several others, whose peculiar behavior is fascinating us. The conclusions we have reached modify the foundations of rational dynamics and incorporate new criteria of great impact and significance. Up to this date, there exists no mathematical correlation in the laws of mechanics that relates the movements of orbitation and rotation, though this fact is constantly repeated in nature. Could there exist a physical correlation between both movements whose mathematical expression has not yet been expressed? The initial experiences allowed us to deduce that, yes, that another rotational dynamic, not Newtonian, exists, which explains the behavior that, in the present paradigm, is supposed to be anomalous, paradoxical, or chaotic, and that the laws we presently have do not allow to identify and predetermine it. We initiated our inquiries investigating how bodies are behaving when they are submitted to different simultaneous accelerations by non-coaxial rotations. That is, if the behavior of a gyroscope, spinning top, or boomerang is exceptional, or it corresponds to general laws of nature that have not yet been formulated. To clarify these doubts, we started several experiments which led us to believe that the investigation should be carried out through the field theory and take into account the concept of dynamics interactions, which means that the generated dynamics fields interact, causing paths that correspond to general laws of physics not yet formulated. Our initial experiments motivated us to establish some dynamics hypotheses, stating that these bodies, under such conditions, realize an orbit movement which follows a closed path without the need for a central force, maintaining its rotation movement simultaneously constant on its initial axis. We carried out a mathematical computer simulation that confirmed that the mobile traced a closed path similar to the orbit traced by a body in space that is submitted to a central force. But in our experiments, such a central force did not exist. Therefore, we were confronted with a new challenge: to reproduce by experiment this path. As carrying out tests in space is difficult and expensive, we decided to continue the tests in water. We designed a cylinder, or submarine, driven by a propeller at the stern, which transmits a translation movement and simultaneously forced it to turn on its longitudinal axis. The submarine also had a torque due to its weight and the upwards flotation force, perpendicular to its rotation axis. We carried out two different prototypes, one with a fixed torque and another with a variable one. The first prototype had a constant torsion torque, as the forces of weight and the upwards force of flotation acted on different fixed points, generating its imbalance. This torque, which we will call interaction torque, forced the submarine to turn on a new axis, the torque axis. However, in line with our hypothesis, we calculated that the cylinder would not carry out this new turn, but would trace a closed circular path. The submarine's speed was radio controlled, but did not have a rudder, nor any other steering device. We started the tests in September 2001. When the prototype was at rest, as it was not balanced, the gravitational torque made the stern sink, staying in vertical position with the bow slightly floating. However, when the motor was started and rotated on its longitudinal axis, the mobile righted and initiated a flat navigation on the water surface in a closed path with a radius that varied in line with the translation speed. Thus, these tests clearly confirmed that the prototype behaved as we had predicted in the realized simulation. The mobile, without rudder but equipped with its own rotation on its longitudinal axis, transformed the action of the second torque in an orbital movement, adding or composing the linear translation speed to the centripetal speed produced by the interaction torque. The resulting path of the submarine was a circle, without the existence of a central external force that generated such path. It transformed into an elliptical one when the mobile speed was modified. As we had predicted, there was a clear phenomenon of cause and effect. We can understand the observed behavior by means of the referred field theory. Suppose we analyze the speed fields that are generated in a section of the submarine which is spinning about its longitudinal axis. The weight and flotation torques generate a second rotation, which is no coaxial, with the existing one on its longitudinal axis. It determines the generation of speed and accelerations anisotropic fields. But something exceptional occurs. This new initial distribution of speeds is modified when the mobile is turning on its longitudinal axis. When the disk is turning on its longitudinal symmetry axis, we obtain a new distribution of the resulting speeds, as can be noticed on the screen. For instance, the quantity of movement of point C will initially be zero due to the new rotation on the perpendicular axis, but as it turns with this new rotation, this new point is also turning on its symmetry axis, and therefore the quantity of movement will increase to reach point A, where the movement quantity will reach its highest level. From there on, the movement quantity will again decrease as, with the new rotation, it will have an opposite sense and will subtract from the one it already had until it will be zero again at point C. We reach the same result, but with a negative sign when we start the analysis in point A. The result is that, in line with the analysis of the generated speed fields, the torques due to weight and flotation generated a new resulting speed field that generates a rotation of the body on a different axis than the external gravitational torque that was acting. The result was the circular path observed. Thus, we confirmed that the rotation generated by the gravitational interaction torque did not correspond to the classic laws of mechanics, nor to vector algebra. After a half-turn, the second rotation was initiated on an axis perpendicular to the torque it generated, and not on the axis of the torque defined by the weight and the flotation thrust. Once we had determined this particular behavior of bodies submitted to simultaneous no-coaxial rotations, and which we agreed to call gyroscopic effect, we continued to analyze the real behavior of the mobile. A new field of speed has been created with the second rotation, but this new field is not homogeneous as the first rotation. It is an anisotropic field of speeds. In line with our hypotheses, this new non-homogeneous field of speeds couples dynamically to the field of translation speeds. This means that both fields are added algebraically while the rotation on the longitudinal axis stays independent. This is our main hypothesis. Our experimental tests confirmed what we had sensed in the realized simulation, that the field of translation speeds of the submarine was coupled to the field of speeds generated by the torques of forces determined by the vectors of weight and flotation. The result was a circular path observed in the submarine, as can also be noticed in the flight of a boomerang or the particular dance of a spinning top. Once we had concluded the tests with the first prototype, we carried out a new test, in which it was possible to steer the submarine to port or starboard by submitting it to an external variable torque. Prototype 2 disposed of a variable torque by means of a pump and 2 water deposits for its transfer. The transfer of water between the deposits of the submarine modified its centre of mass, which allows to sink the bow or stern, and thus change the gravitational interaction torque. The tests we carried out with this prototype totally confirmed our theory. We had achieved the steering of the mobile to port as well as to starboard in line with the variation of the gravitational torque. The submarine could be steered without rudder, according to the dynamic hypotheses of the theory of dynamic interactions. The result of our experiments confirmed our initial doubt. A correlation can exist between rotation and orbitation, and therefore a body with intrinsic angular momentum and translation speed submitted to a real non-coinciding torque transforms its dynamic action in a precession movement which, in case the torque is constant, will generate a flat path with closed orbit. We have developed and confirmed a theory of dynamic interactions, which laws justify the peculiar behavior of revolving bodies equipped with intrinsic rotation on its main axis. We also have deduced a movement equation which allows us to predetermine the behavior of the mobile for an idealized model without nutation. I developed this dynamic model and its background in 2 books about non-Newtonian mechanics: The Flight of the Boomerang, an essay in honor of the physicist Miguel Catalan, and A Rotating World. This theory has been presented at national and international scientific congresses and in various articles in scientific publications. The result of this investigation project is the demonstration of a rational fields theory that allows a new understanding of the behavior of the universe and matter. The application of these dynamic hypotheses to astrophysics, astronautics, and other fields of physics and technology will allow new, surprising, and stimulating advances. It is up to you now. I need your collaboration. Use your scientific doubts and analyze, dissect, look for its weak points, and refute the theory of dynamic interactions. Discuss it with other scientists, and carry out any needed experimental tests. I would like you to participate in this project that shows the way to a new scientific model. Thank you very much.